Hello students, welcome to the video lectures of speech and natural language processing. Today we'll talk about unit selection waveform synthesis. Unit selection waveform synthesis is a speech synthesis technique that generates natural sounding speech by selecting and concatenating pre-recorded speech units from a large database. This method ensures naturalness by using speech samples directly from a human speaker, minimizing the need for artificial processing. So let me come again. So hope you understood. Unit selection waveform synthesis is a speech synthesis technique. So that generates natural sounding speech by selecting and concatenating. So pre-recorded speech units. So these pre-recorded speech units are nothing but smallest sound units that exist. So what are those? Those are phonemes, diphones, syllables or words from a large database. So this method will ensure the naturalness by using speech samples directly from a human speaker, which minimizes the need for artificial processing. Okay. So basically, if you observe the text to speech systems, so this unit selection waveform synthesis is the best one we can say, where it tries to generate the natural sounding speech by selecting and concatenating the pre-recorded speech units as mentioned here. So basically, what are these units again? These units are typically the small segments of human speech, okay, such as diphones, phonemes, syllables, or words, as mentioned here. So basically, a speech corpus is created, and where the text-to-speech system will try to analyze the input text and select the most appropriate speech unit from the existing database or corpus, what we have created already, where it tries to match the phonetics or the prosodics, all these things, and then concatenation will happen where once the units are selected, they are concatenated to form a continuous waveform. So this tries to match everything. So as I said, you phonetic match or prosodic match and everything. That is how unit selection waveform synthesis works. So let us see the key concepts in this now. So first one, speech units, the basic building blocks of synthesis. Units can vary in size. Phonemes, smallest sound unit. Diphone, transition between two phonemes. The syllables, so which are units of pronunciation. Words, entire words. For example, the word cat, the units could be phonemes are these or diphones these. Okay. Then, a unit database, a large repository of pre-recorded speech data is the database associated with this. Next, which covers multiple instances of each unit to account for different contexts. Examples are stress, pitch, duration. Then unit selection. The synthesis algorithm selects the most suitable units from the database based on target cost and join cost. What is target cost? How well the unit matches the desired prosody. Prosody as in the pitch, duration, stress. Since the prosody is about the pitch, intonation or duration and stress. Next, join cost. So how seamlessly the unit joins with the neighboring units is join cost. That is your acoustic similarity, we say. Next step is concatenation. So selected units are concatenated to form the desired utterance. Smoothing techniques ensure natural transitions. So steps involved in unit selection synthesis. So before I get into this, steps which are involved in this unit selection synthesis, like text analysis, prosody prediction, unit matching, concatenation and smoothing or output speech. So just try to align the same thing with a real-time example of unit selection waveform synthesis, like your Siri of Apple's or Google Assistant, or you can consider Amazon Alexa. So for instance, if we say when you ask like Google Assistant, so what is the weather? What the weather, like today? So what's the weather likely be today? So it generally processes it, right? So it takes the text input, whatever you have spoke. Okay. So you told that. So what's the weather like today? And it uses all the NLPs, okay, and then it has this its unit selection where the system will break down the sentence into smaller units like phonemes or syllables or words, and it searches the large database with of pre-recorded human speech to find the most appropriate match for those units, whatever we have asked it, okay, about the weather condition. Then once the system selects the best matching speech units from its database, it then concatenates into continuous audio stream. Okay. So then what happens is the system will then play back the generated speech in real time. Like since you asked for what's the weather today, so the weather is sunny with a high of 75 degree Fahrenheit, something like that. That would be the real time output. What you will be getting out of this unit selection waveform synthesis. So basically, this is a TTS, that is text to speech example. And in real time, you can consider this series or Google Assistant or Alexa. So hope you got the point what exactly this unit selection synthesis or what that concept is all about. So then we just jump into the steps now. So first is text analysis. So input text is analyzed and converted into a sequence of phonemes or other linguistic units. Example is hello. Okay, these are the sequence of the phonemes. H E L O. Okay, H E L L O. Hello. So the phonetic conversion. Next is prosody prediction. So that is desired pitch, duration, and stress are estimated for each unit to match the context of the sentence. Next is unit matching. So the system researches the database for units that match the predicted prosody, low target cost, and blend well with neighboring units. That is low join cost. Next is concatenation and smoothing. So selected units are concatenated to generate the speech waveform, and signal processing smooths boundaries between units to avoid artifacts. So next last step is output speech. The synthesized speech is played back. So you can just incorporate or you can just understand the steps in unit selection synthesis with the real-time example just I revealed with your Siri or Google Assistant or Alexa, where the text input is taken, then the unit selection is happening. That is, the unit selection is nothing but the system will try to break down. So this given sentence into smaller units, which we call them as phonemes or syllables or words. And then what it does is it already have a pre-recorded database of human speech, right? It just compares it with that. Then your waveform synthesis will happen. Okay, so it tries to concatenate into continuous audio stream. Then the real-time output will happen. Okay, next, advantages of unit selection synthesis. First is high naturalness. Use real speech recordings, resulting in highly realistic output. Just as we have seen, what would be the weather today? So then we got a reply that's yes, the weather would be 75-degree Fahrenheit with some sunny, etc., etc. So it sounds more natural. Second is prosodic variation. By selecting from multiple instances of a unit, the system can better match the desired prosody. Language flexibility can be adapted to different languages by recording a new unit database. Absolutely right. So whenever you want to apply this or whenever you need a more natural way of sounding, you just need to have some database with you which have the pre-recorded thing. Then challenges. So first one is database size. Absolutely, because the entire scenario or the entire activity is based on the database itself. So that is the reason why this database would be a biggest challenge. See the challenges. First one is database size, which requires a large and comprehensive database to capture all possible contexts. Example, a diphone based system for English may need thousands of diphones recorded in multiple contexts, right? Second is boundary artifacts. So concatenation can introduce audible artifacts if units are poorly matched or transitions are not smooth. Just have this concatenation concept with your Alexa series. Just now I revealed and we asked it what is the weather now. So imagine what are the various challenges that you can face when the system is trying to match or concatenate the couple of words which are taken from the pre-recorded database and giving you the output. So then you can understand this boundary artifacts. So when the units are poorly matched. Okay. Third one is storage requirements. High quality databases require significant storage space. So absolutely. Fourth one is limited expressiveness. The naturalness is constrained by the database recordings and may lack variability or emotion. Next, applications. As we are being, discussing the Google Assistant example or Alexa or Siri, whatever. So that which falls under your TTS, that is text to speech systems. So that is the application. Common in virtual assistants, automated announcements, and accessibility tools. Second is language learning tools, which provides natural sounding speech for teaching pronunciation and intonation. Third is entertainment. It's used in video games and animations for creating character voices. Example workflow is given. I love programming. So steps involved. First is text analysis. Converts text to phoneme sequence. So you can see the phoneme sequence. Next is prosody prediction. So predict pitch, stress, and duration. Okay. So the given input text is I love programming, right? So here I and love both are considered in prosody prediction. You can see here. So I, which are higher pitch, short duration. Love, neutral pitch, slightly longer duration, right? So I love, okay. So I is having higher pitch but short duration, where love with neutral pitch but longer duration. Third is unit matching. So it retrieve units from the database that match both the phoneme sequence and desired prosody. Fourth is concatenation and smoothing. So join the selected units and apply smoothing. The fifth step is output speech. So generate and play the synthesized sentence. That is about your unit selection waveform synthesis. Thank you, students.